Have you ever just stopped to think how absolutely wild language is? I mean, really, of all the creatures on this planet, we're the only ones who can gossip about what happened last week, make plans for next year, or even argue about whether Santa Claus is real. So, how do we do it? How does a tiny gurgling baby turn into a grammar master in just a couple of years? Well, let's dive into that miracle, because that's what we're talking about today.
So picture this. It's the mid-'80s, you're taking a walk past the Boston Aquarium, and all of a sudden you hear this gravelly voice yelling, "Hey, hey, get out of there." You look around, maybe for a security guard, but nope. The only one there is this big harbor seal chilling in his tank. Turns out the seal had actually learned to imitate human sounds. And this story is the perfect jumping-off point, because it makes you ask, what's the real difference between a clever mimic and the incredible creative power of actual human language?
To answer that, we've got to first figure out what makes our language so special to begin with. It's not just about making sounds. Human language has this unique set of design features, a kind of blueprint that turns it into a genuine superpower.
And this breakdown right here shows the key differences perfectly. Look, all creatures communicate, sure, but they're mostly trapped in the here and now. They have a fixed, limited set of signals. A dog's bark means bark, right now. But we humans, we're playing a whole different game. We can talk about the past, we can invent brand new ideas, and we can pass it all down through our culture. Let's just zoom in on a couple of these superpowers.
Okay, first up is this thing called displacement. This is basically our ability to time travel with words. When your dog growls, that means growl, right now. It can't tell you about that scary growl it heard at the park yesterday. But we can. We can talk about things that aren't even here, things that already happened, or things we hope will happen. This is the feature that gives us history, planning, and even stories about Santa Claus. And then there's productivity, which is really just a fancy word for creativity. Think about it like this. Vervet monkeys have one specific danger call for snakes and another one for eagles. But what happens if they see some bizarre flying snake thing? Well, they can't mix and match their calls to create a new warning. They're stuck with their menu. But us, we can create a literally infinite number of new sentences. We can describe anything, even a flying snake, because our language is an open, creative system, not a closed one. So we have this incredible language toolkit. But how do we get it? Well, the answer starts with this amazing journey every single one of us took as a kid, learning our first language, or what linguists call our L1. And what's wild is that this timeline is almost universal. It doesn't matter where you are in the world or what language you're learning, kids follow these steps. It starts with simple cooing, then they get into babbling, where they're basically just practicing all the sounds. Then you hit the one-word stage, where a single word like cookie can mean, I want that cookie right now. And before you know it, they're stringing words together in what we call telegraphic speech, kind of like an old telegram, just the important words. Cat, drink milk.
This little conversation is so revealing. The mom tries to correct the child, right? She offers the correct word, held, but the child sticks with hold it. Now, why would they do that? It's because the kid isn't just copying adults. They've figured out a rule in their head to make something past tense, I add ed, and they are applying that rule everywhere. This mistake is actually a sign of pure genius. It's the kid's brain actively building the rules of grammar from scratch.
Okay, now it's your turn. Let's try something. This comes from a super famous experiment called the WUG test. It was designed to figure out if kids are just memorizing words or if they actually understand the rules. So if I show you this little creature and tell you it's a WUG, what would you call two of them? There are two. If you said WUGs, congratulations, you just did exactly what pretty much every child does. And think about that for a second. No kid has ever heard the word WUGs before. They can't be copying anyone. They just instinctively apply the rule for making a plural. This is the smoking gun. It proves beyond a shadow of a doubt that children are learning a complex system, not just a long list of words their parents taught them. And this just brilliantly shows how that rule learning happens in these clear, predictable stages. I mean, just look at how a child learns to say no. It starts simple. No cookie. Then the no moves inside the sentence. Then they start using words like don't for everything, before they finally nail the complicated system of matching it to the right verb, like doesn't. It's like watching a building being constructed, one floor at a time.
Okay, so if learning our first language is so natural, why does learning a second language as an adult feel like trying to climb Mount Everest? Well, it's because it's a fundamentally different journey, one that's totally shaped by the language you already have in your head.
Now, sometimes your first language can give you a real leg up.
This is something called positive transfer. If you're a Spanish speaker learning English, for example, a word like exterior is basically a freebie. It looks the same, it means the same thing, you just transfer that knowledge right over. It makes parts of the process feel way more intuitive.
But then, of course, there's the flip side. Negative transfer. This is where the rules of your first language actually trip you up in the new one. So, for instance, in Korean grammar, you don't always need a verb like was in a sentence. A Korean learner might logically say, last week, climate warm, leaving out the verb. It's not a random mistake. It's an error caused directly by the grammar of their first language interfering, and it's a huge part of the challenge for second language learners.
This all means that the language an L2 learner speaks isn't just a broken version of the target language. It's actually its own complete system, with its own consistent rules. And we call it an interlanguage. It's sort of a mashup of L1 rules, L2 rules, and some other creative solutions. And what's really interesting is that sometimes learners hit a plateau where certain errors just become a permanent part of how they speak. That's a process called fossilization.
So, what is actually going on inside our brains when all this is happening? For decades, linguists and scientists have been debating this. What's the fundamental engine that drives this incredible feat of language learning?
Well, the whole debate really boils down to three main camps. First, you had the behaviorists, who said it's all about habit. You imitate what you hear, you get a cookie for saying milk, and that behavior is reinforced. Simple. Then came the linguist Noam Chomsky, who completely changed the game with innatism. He argued we are not blank slates. We're actually born with a universal grammar hardwired into our brains. And finally, you've got the interactionists, who say, hey, it's not just genes or the environment. Language is forged in the back and forth of talking to other people.
And this debate brings us right to the brain itself, and to one of the most fascinating and honestly controversial ideas in all of linguistics, the theory that there might be a biological deadline for learning a language perfectly. This idea is called the critical period hypothesis. It basically suggests that a child's brain is like a super absorbent sponge for language, but that after puberty, that sponge starts to harden. The window of opportunity for that effortless, perfect language acquisition starts to close. It's a really powerful theory that tries to explain why little kids seem to just soak up language while adults often have to fight for every word.
One of the most famous and frankly tragic cases that seems to support this is the story of Jeannie. She was discovered at age 13 after a childhood of unimaginable abuse and isolation, with almost no exposure to language. After she was rescued, she was able to learn a lot of words, a big vocabulary, but she never mastered the complex rules of grammar. Her senses stayed very simple, very telegraphic, suggesting that the window for learning grammar had tragically closed for her.
So, when you put it all together, what's the big takeaway? The crucial point is that this language miracle isn't magic at all. It's a predictable, explainable process. It's this powerful combination of two things: a brain that comes pre-wired for language, our innate blueprint, and the thousands upon thousands of hours of real, meaningful interaction that feed and shape that natural gift. You need both. You need the hardware and the software to make it all work.
And that kind of brings us to one last big thought. We don't just use language to describe the world around us, we use it to build our reality. Every language offers a completely unique way of seeing, of thinking, of being, which leaves us with a pretty deep question to think about. If learning a language gives you access to a whole new reality, how many of those realities can you make your own?